Bismillah Rahman Rahim. In this session, we will discuss nuclear model of the atoms under the subject of IGCSE and O level physics. And this topic is basically, or the content is taken from the book of Tom Duncan and Heather Kennett, 2021. And this book, the publishers are Hodder Education, and this is highly recommended book for O level and IGCSE students. Today we are discussing the nuclear model of the atom. Before the discovery of electron and radioactivity, it was assumed that atom is indivisible, but later on, with the discovery of electron and some radioactivity phenomena, it was assumed that if electron is indivisible, then how the particles are positive or negative charge particles are arranged inside the atom. And so with the experiment of Geiger and Martin on the scattering of alpha particle from thin metal film, it revealed the nuclear model of the atom. And in early theory, the atom model was assumed as a plum pudding model. It was assumed that atom has a plum pudding model, and where the pudding is all positively charged sphere. The atom is a positively charged sphere in which the negative electrons were distributed all over it. So atom is like a sphere, and where the electrons are embedded on that sphere like a current in a pudding. So this was the initial model assumed for the plum pudding model, and in sufficient number to make electrons electrically neutral. So the number of electrons and positive charge atoms were electrically neutral, so that electron charge and the atom's positive charge should be equal to make it unneutral. So it was assumed, this plum pudding model. But later on, some experiments cast doubts about this model. So this model was incorrect. The structure of an atom is not described in terms of negatively charged electron orbiting a positively charged nucleus. With some experiment later on, it revealed that electron orbits the nucleus, positively charged nucleus. So with the scattering experiment, Ernest Rutherford noticed that not only could a particle pass through very thin metal foil as if it was not there, but also some alpha particles were deflected from their initial direction. So Rutherford observed some particles pass through very thin metal of the foil if it were not there, but also some alpha particles were deflected from this initial direction. So in an experiment of Hans Geiger and Martin, this was the experiment rather investigated in Manchester University in UK, and here we have a source, alpha particle source. It was bombarded on a gold foil, and experiment was conducted in a rotating rotatable microscope. So this was a rotatable microscope, and the alpha particle was emitting from this radiating source, and it bombarded on this gold foil, and it was observed that some of it was deflected with zinc sulfide, and some reflected, some deflected, some reflected, and some passed through it. So with the result of this, the fate of alpha particles also striking the gold foil was detected by the scintillations they produce on a glass screen coated with zinc sulfide and fixed to a rotatable microscope. So it was striking, and some of it was reflected, some passed through, some deflected. This creates some doubts about that plum pudding model, and they found that most of the alpha particles were undeflected. It was undeflected, passed through it. Some were deflected and produce a glass screen coated zinc sulfide and fixed to a rotatable. We found that alpha particles were undeflected, some were scattered by appreciable angles, some deflected, and very few reflected, and few, about 1 in 8,000, surprisingly bounced back. Bounced back means reflected. It was very few of them reflected. So this was the observation that Rutherford observed, and he explained the nuclear model of the atom, in which all the positively charged and most of the mass of atom formed a dense core. With his experiment, he described that all the positively charged and most of the mass of an atom form a dense core or a nucleus of very small size compared with the whole atom, and the electrons surrounded the nucleus some distance away. So this was the Rutherford model. He derived a formula from the number of alpha particles deflected at various angles, assuming that the electrostatic force of repulsion between the positively charged on an alpha particle and the positively charged on the nucleus of a gold atom obeyed an inverse square law. That is, the force increases 4 times if the separation is half. So the alpha particle and the nucleus of this atom, the gold foil atom, it was striking, and as a result of this, it has observed this experiment, this results, and where some inverse square law was also obeyed. And Giger's and Martson experiment results confirmed Rutherford model formula and supported the view that an atom is mostly empty space. So if more is passing, means there is no abstraction. So the space between the nucleus and the orbiting electron is so large that these alpha particles pass through very easily, and only if very few of the particles bounce back, and some deflected. So in fact, the nucleus and electron occupy the 1/millionth of the volume of an atom. So the nucleus is very converged, very small size as compared to the atom. The nucleus is like a sugar lump in a very large hole. So from this model, that it was observed, or it concluded that the nucleus is like a sugar lump in a very large hole, and the electrons are swarm of flies. So this was the Rutherford conclusion, and from this, that the atom of the gold foil, this is the atom of a gold foil, and this is the nucleus, so positive charge nucleus, and number 1 is this is if this is alpha rays and is passed through very easily, and here in a 2 it gets some deflection, and in case of 3 it gets bounce back. The particle 1 is clear of all nuclei and passes through the gold atom. It passes through the gold atom very easily. So this one number passes very easily. The particle 2 is deflected slightly here, and particle 3 approaches a gold nucleus so closely it's here in this third number of particle, it strikes with the nucleus so that it violently repelled by it, and rebounds appear to have had a head-on collision. So this was observed, and the Rutherford model was later on refined. Bohr's, a new scientist. So shortly after Rutherford proposed his nuclear model of the atom, Niels Bohr, a Danish physicist, developed it to explain how an atom emits light. He suggested that the electrons circled the nucleus at high speed. So this is electron and circled the nucleus with a very high speed. This is nucleus, this is electrons, and this is nucleus, and it circled it very high with a very high speed, being kept in a certain orbit by electrostatic attraction of nucleus for them, and being kept in a certain orbit. So this electron, they maintain this position because of the electrostatic attraction of the nucleus. And he pictured atom as a miniature solar system like this. And normally if the electron remains in the orbit, but if atom is given energy, when atom gives energy, for example by being heated, electron may jump to an outer orbit from here to here. If it gets energy, it moves up. The atom is said to be excited. Very soon afterward, the electron returns to an inner orbit. Suppose if electron jumps to this orbit and then it returns back, so that it emits lights. So energy is transferred by burst of electromagnetic radiation called photons. So in that case, if electron return to this, suppose this is excited to reach to the outer orbit, and after some time, if return back, it radiates some radiation out. And this was the Bohr's explanation, such as an infralight or ultraviolet or X-rays, it emits photons. The wavelength of the radiation emitted depends on the two orbits between which the electron jumps. So this wavelength of this, or the type of radiation or the strength of the radiation, depends upon the two orbits between which the electron jump. This was the details of Niels Bohr about the electron movement across the different orbits. And the atom gain enough energy of electron to escape altogether, the atom becomes an ion. If atoms gets enough energy of electron to escape altogether, if electrons moves away from this whole atom, then it becomes a positively charged, and this is called the ionization energy of the atom. So the energy, the amount of energy, if some atom gets some energy to remove the electron to make it ionize. So ions, a normal atom is a neutral with no net charge. If a negatively charged electron is lost, the atom acquires a positively charged and is termed as positive ion. If electrons are removed from an atom, then it becomes positively charged. It becomes ionized, or it becomes a positive ion. When an extra electron is gained by an atom, then it becomes negative ion, negatively ionized. So a negative ion creates because electron contains a negative charge. Such electron exchange forms a binding of atom together in a molecules and in crystal structures. So This was some of the questions from test yourself from this book, and here how describe how charge and mass are distributed in an atom. So the physicist Bohr suggested that the electron circled the nucleus. The electron circled the nucleus at or orbiting the nucleus at very high speed, being kept in a certain orbit, this orbit or this orbit or any other orbit, by electrostatic attraction of the nucleus for them. So Bohr suggested that electron orbits the nucleus at very high speed, being kept in the certain orbit by the electrostatic attraction of the nucleus. Because of this electrostatic attraction, it maintain its orbiting positions. So some of the pictures has shown this Bohr's structure of atom. Normally the electron remains in their orbit, and if it gains energy, it's heated up to move to the outer orbit, and if an atom is said to be in excited state, soon after the electron returns its energy and return to the inner orbit, then it radiates energy, and that's electromagnetic radiation is called photons, as we discussed earlier. So this is that how charge and mass are distributed in atom. This is nucleus. This is the total mass, concentrated mass inside the nucleus, some of the electrons outside, and that electrons are maintained in its position orbiting due to this electrostatic attraction, and certain orbits the electrons are rotating due to this electrostatic attraction, and if some electron gets energy, it's moved to the outer orbits, and once it releases energy, it's released in terms of electromagnetic radiation or photons. So how can a positive ion be formed from a neutral atom? If electrons are taken away from the atom, then it becomes positive ion. If it gets some electron, then it becomes negative ion. And such electron exchange forms a way of binding electron together in molecules and in crystal structure. This is now the nucleus. The nucleus of an atom is composed of positively charged proton and uncharged neutrons of very similar mass. So nucleus was consist of protons and neutrons, and their mass was comparatively the same. The properties of an atom are determined by the number of protons, but the number of neutrons can vary to give different isotopes of same elements. So the number of protons basically defines the properties of the atom, and the number of neutrons may change in the same atom, then that is called the isotopes of that element. So some heavy nuclei are unstable and break up into multiple parts in a nuclear fission, and light nuclei may combine in nuclear fusion. They attach, they combine, and in nuclear fission they disintegrate. Both processes emit substantial amount of energy. In a fission process or in a fusion process, both processes emit substantial amount of energy. So proton and neutron. The proton is a hydrogen atom minus an electron. Electron consists of a proton and a nucleus in its orbit. If the electron is taken away, then it becomes a positive hydrogen ion, and its charge is equal in size but opposite in sign. The electron charge is negative, proton charge is positive, but its mass is almost 2000 times greater. So the mass of proton is or neutron is 2000 times greater than the electron. So neutron is uncharged with almost the same mass as a proton. So the proton and neutrons are in the nucleus are called nucleons. So the proton and neutrons in a nucleus is also called nucleons. This is proton, and the mass of the proton is approximately 2000 atomic mass unit, and neutron is almost same, and the electron mass is 1 AMU. So this has a positive charge, this is no charge, and electron is negative charge. Outside the nucleus, it is inside the nucleus. So this is this table basically defines the atoms, the mass and its charge. So in a neutral atom, the number of protons equals the number of neutrons surrounded the nucleus. In a neutral atom, the number of protons and number of electrons are always equal, and electrons surrounds in the nucleus while the protons are available in the nucleus. This is test yourself, and this question number 3 is available on page 257. An atom consists of proton, neutron, and electron. Which of the following statement is not true? An atom consists of a tiny nucleus surrounded by orbiting electron. This is a correct statement. The nucleus always contains proton and neutron called nucleons in equal numbers. The number of proton or neutron may have different numbers inside a nucleus, so this is incorrect. So the B is incorrect statement. A proton has a positive charge and a neutron is uncharged. This is correct. The electron has a negative charge of the same size as that of charge of a proton. This is also correct. So this statement B is incorrect. A lithium atom has a nucleon number of 7 and a proton number of 3. State the number of nucleons in the nucleus. So number of nucleons is 7, and the proton in the nucleus is 3, and neutron in the nucleus is A minus Z, is total number of nucleons minus number of protons. So this is 4. So there are 4 neutrons inside the nucleus, and the electron in the neutral atom is equal to the number of protons. So this is also 3. So total mass number nucleons is 7, proton is 3, electron is 3, and the neutron is 4. So give the symbol of a lithium atom in a nuclide notation. This is 7, this is 3, this is called the proton number or the mass number, and this is the nucleon numbers. This is the proton number and this is the nucleon number. So an atom of sodium has a symbol this. So the number of Z and A is Z is equal to 11 and this A is 23. How many protons are there in the nucleus? So there are 11 protons. The atom of helium has a symbol of 2He4. State the charge of the nucleus of the atom. Charge of the nucleus is positive due to the 2 proton inside the nucleus. So the number of proton inside the nucleus is 2, so the nucleus is positively charged, while on the outer orbits there are 2 electrons that neutralize this 2 positive charge. An atom of chlorine has a symbol of 17 and 37 Cl. State the nucleon number of atoms. So here the number of nucleons are 37. Explain how the nucleon number is related to the mass number. The mass or nucleon number of an atom is the number of nucleon in the nucleus. In general, the number of neutron in the nucleus is A minus E. This is nucleon number and this is proton number. So this the difference is gives the neutron in the nucleus. So atomic nuclei are represented by the symbol written as 11H, helium as 2He, and lithium as 37Li. In general, X is written as in nuclear notation as XZA. A is the nucleon number and Z is the proton number. So this will be discussed in the next session.